Lesson 812, I'm going to go over some of these problems briefly. You should have worked on these already in class, but here's some ideas and hints and kind of what we've learned previously to this point. So the very first problem, part A, if I would multiply all these out, I would end up getting an x cubed as my leading coefficient, which means this is a third degree polynomial. If it's a third degree polynomial, that means it's going to follow this form. It's either going to look like this or it's going to look like this. Now the difference between those is the orientation. Since when I would multiply it out, I would have a positive x cubed. That would be this one. That is a positive orientation, and I'll actually talk a little bit more about that the next problem. So problem B. If I would multiply all these out, I would get an x to the fourth. So it is a fourth degree polynomial. So it's going to look something like this. Again, for this one, we are not getting too exact. You're basically, as it said in the picture in the diagram, we're just writing these out or sketching them in the air with our fingers. So we're not getting super accurate with this. The difference here for problem C now is they have a negative right here. So instead of it looking like this, it's actually now going to be upside down. So it's going to have a negative orientation. And again, I'll talk about that on the next problem, but it's now going to look more like this, more like an M instead of a W because of the negative out front. Problem D is also going to be fourth degree. We have this one squared and this one squared, so I'd still have x to the fourth as my leading, or as my highest power. So it's going to look, again, like this. The difference here with this one is with those being squared, and again, we're not really using our x and y axes, but if I would use my axes, they would have intercepts at -7 and at +7, and they would bounce off because of those both being squared. Again, I'll talk about that in a later problem on this lesson, but that is something we discussed in class from lesson 8.1.1 as well. And the last problem, it is going to be a fifth degree polynomial. If I multiply all that out, it'd be x to the fifth, which means it's going to look something along the lines of this. So if I take a look at the next problem, problem 27 wants to know if I have a degree 3, how many possible roots could I have? So a third degree polynomial, again, will look like this. So if I have an x-intercept or an x-axis right here, that x-axis right now is intersecting it once, but it could actually intercept it multiple times. If I would go here, now I could have 2 intercepts, and now I'd have 3. I cannot get more than that. So the most that a third degree polynomial could have would be 3 roots. So the next problem, if I have a degree n, it could have at most n roots. So looking back at the previous problem, just to give an idea, so if that is my x-axis right there, I'm going to have 5 roots. So this question here kind of already answered it. If we look at the example of the third degree, again, if I would just move this x-axis down here, I would have 1, so it can have fewer. If we look back at the previous problem here, if I would move this down, I could have fewer as well, or if I moved it up, my x-axis. So on problem 28, so we're looking at the minimum degree that each of these could have. So because of the shape here, this would end up having to be a third. This one here would end up having to be a second. It looks like a parabola. This one would end up having to be a fourth as its minimum degree. And this last one would end up being a fifth at its minimum degree. So both of the classes when we did lesson 811, sort of talked about how many times your direction changes as your degree. So 1, 2, 3, 1, 2, 1, 2, 3, 4, and 1, 2, 3, 4, 5. That's sort of how we're getting those. However, the part A then after that is talking about what happens as x gets larger and larger. So if I would just put in an x and a y axis, it doesn't matter where the x and y axis, but as the x values increase this direction, your right arrow will either be going up or down. So based off of what's happening with that arrow, as x increases on this first one, this y value keeps going up and up, which means that is positive orientation. If I would go through and take a look at, say, this graph, as x gets larger and larger, these y values keep going negative. That is now your negative orientation. Again, looking at the last two examples, the right arrow is going up, it is positive orientation, and this would again be negative orientation because that right arrow is going down. Problem 30, talking about double and triple roots. So this right here, this is the problem, the very first one we looked at actually in the lesson from 8.1.1 when we had those set of polynomials. So if I think of what this will look like, I have, because of that factor, I have a root at 2. And because of that factor, I have a root at negative 5. Now, the x plus 5 squared, that is now called a double root. So going back to how many degree, or a third degree polynomial can have 3 roots, well, this one now only has 2 roots. And that's because if I would write this out, it'd be x minus 2 times x plus 5 times x plus 5. We don't write this out like that. We use the square to replicate that. So, but those are both going to give me the exact same x-intercept or root. So therefore, it is called a double root. And what effect does it have on the graph? Well, it's going to bounce off of that at the x-axis. So if I know that this is going to be a third degree polynomial, so it's going to look like this. It's going to have positive orientation, so it'll look like that instead of looking like this. That means as it gets to this intercept, it'll bounce, and then it'll go through that one. So there's a sketch of what that looks like. If it is a triple root, so for instance, if this problem, instead of being squared, if it was cubed, I still would only have those two x-intercepts. But now this is a fourth degree polynomial, which means my arrows will both be going the same direction. So my arrows will both be positive. As I come to this x-intercept, it's going to go through it like a cubic. And then it's going to come around and then go through straight there. So the graph would look something like that. That is now a triple root because that has been cubed. The root there is a triple root. It looks like a cubic going through it. Problem 31. If you've not already attempted these, maybe after I do problem A, perhaps you want to pause it and then try it by yourself. But if I look at problem A, I have -3, -1, +4. It is shaded here and shaded here. The shading means it is above the graph. So my graph would have to be below, then above, below, and then above. I know what my factors are because of those roots. So my factors have to be x plus 3, giving me the -3 root, x plus 1, and x minus 4. and there's my equation. So pause it, try problem B, and I will go through and do problem B in a couple of seconds, and then do the same thing for C and for D. Okay, hopefully you have paused it now here and tried out problem B. So I have a -5, I have 0, and 2. Shaded here and shaded here. So my graph is going to be negative over on this side. Then it's going to go positive. I have an x-intercept here, but it stays positive, and then it goes negative. So I have a factor of x plus 5. From this one, I would have x plus 0, but we normally don't write the plus 0, so it's going to be just x. And then we also have a factor of x minus 2. Now, because of the fact that it bounces here, I know that this has to be at the least squared. It could be a 4th power, it could be a 6th power, but I know it needs to be at least squared. Now, it also has negative orientation, which means my equation has to have a negative value out front. So there's my equation. And go ahead and pause it and try C. Okay, hopefully you paused it and have something written here. I have above, and then below, below again, and above. So similar to the last problem, I have something bouncing. My factors are going to be x plus 1. My next factor is going to be x minus 1, and since it bounces, it's squared. And my last one is going to be an x minus 4. Positive orientation, so it's going to stay positive. So there's my equation. And go ahead and do problem D while I set it up. All right, so I'm below, then above, below, above, below. 4th degree polynomial, negative orientation. So I have a negative, x plus 2, x plus 1, x minus 1, x minus 2. And those are all possible graphs. And then the last problem, 8-35. So now with all the things we know, if I'm going to make rough sketches for problem A, I'm going to have negative orientation. I have intercepts at 0, -1, and +3. So with negative orientation, my arrow is going to end down. It is a 3rd degree polynomial, so my arrows are in opposite directions. And it's going to go through and through and through. And there's my graph. Pause it and try B. Okay, so for problem B, it is going to be a 4th degree. Intercepts at 1, -2, and +4. 4th degree means my arrows are in the same direction. Positive orientation means my arrows are both going to be up. It is going to bounce at this one. So at this point right here, it will bounce because it is squared. So it's going to go through, bounce, and through. For this one as well, I could actually mark my y-intercept. If I take a look at this graph and I put in 0 for all my x's, I'm going to get negative 1 squared times 2 times negative 4. So I have 1 times 2 times a negative 4. So my y-intercept will be negative 8. And pause it and do problem C. Okay, again, this problem, it is a 4th degree. I have roots at negative 2. That is a triple root. And then at positive 4. 4th degree, positive orientation, arrows both up. It's going to go through this one like a cubic. And then through that one. I could, again, figure out my y-intercept. If I put in 0 and 0, I would have 2 cubed times a negative 4. That is 8 times a negative 4. So that would be a negative 32. Hope that helped.